Hi everyone, welcome to our session, Optimizing Compute for Performance and Cost. I am Aparajita Jas, a Senior Business Development Manager with Amazon EC2. We have a lot to cover, we'll get started soon. Some housekeeping items before I start. There will be a live Q&A at the end of the session. But I also have a team here that can help answer questions during the presentation. Please don't hesitate to ask your questions in the chat window. If we are not able to get to your question now, we'll address them at the end. In terms of agenda, I'm going to take you through how AWS is able to provide compute for virtually every workload. I'll talk about pricing optimization, capacity optimization. Then I'll talk about how we use the tools that AWS provides to optimize for performance and cost across the pricing and capacity optimizations that I just mentioned. I'll help you understand how to take some guidance and best practices into consideration, and then we'll wrap up with the conclusion. I did try to include links for additional information as best as we can in terms of the pages. So I encourage you to follow those links and learn more as we go through this. All right, let's get started. A bit of history lesson here to give you more context. Back when we launched EC2 in 2006, we offered only one instance type. It came with one vCPU and 1.7 gigabits of system memory. We allowed you, the customer, to only pay for what you used and scale up and down as quickly as needed. Until EC2, the only option was for customers to build their own data center, procure and manage hardware with long-term commitment. Fortunately, we did not stop there. 90% of our product roadmap is influenced by direct customer feedback. We heard from you that you needed more options to address the needs of different workload types. Your needs changed, and we continue to innovate to support that. As a result of those efforts, we now offer the broadest and deepest compute platform, including 400 plus compute instances with a wide range of processors and architectures to choose from. We have invested in new capabilities over the last year, such as faster processors, introduce new instances for accelerated computing, and enhance networking to remove network bottlenecks for high-performance workloads. You can also add options such as elastic block storage for storage, elastic inference to reduce costs of running deep learning inference, and elastic fabric adapter as a network interface for any supported EC2 instance to run applications that need these. All of this comes together, we plan to continue to bring new instances to market to support every conceivable workload our customers may have. And these options give you the power of choice to select the best instances for your business needs. We are also providing you with the choice of processor and architecture to build the applications you need with the flexibility you want. We have 3 processors for you to choose from. The first one is Intel. Since 2006, AWS has had a long-term partnership with Intel, and their processors have been essential to powering our most powerful instances. Amazon EC2 instances powered by Intel Xeon Scalable processors have the largest breadth, global reach, and availability of compute instances across AWS geographies. Next, we have AMD, which we launched in 2018, and we are seeing strong adoption for their instance types. This can also provide you with cost benefits of up to 10% over the Intel ones. And finally, we have AWS Graviton 2, our very own processor that we launched a couple of years ago based on ARM architecture for server workloads. And I talk more about it in the next slide. All these processors and the instances they power have enabled customers like you to run compute at cloud scale with our EC2 instance portfolio. Graviton 2 is the latest generation of AWS instances powered by the ARM architecture. We have multiple different instance types: general purpose, compute optimized, memory optimized, and the burstable general purpose available for a free trial if you're interested. The value that Graviton 2 processors provide to you is up to 40% better price performance when compared with our other comparable instance types. Java applications, RDS databases, containers, and EDA, electronic design automation, are few examples of very suitable workloads to run on Graviton platform. Keep this in mind as you're choosing the right instance for your workloads. We also offer a broad choice of accelerators to help you add capabilities to workloads that can benefit from them. From left to right, we have the NVIDIA A100 Tensor Core and T4 Tensor Core GPUs. Then we have the Xilinx FPGAs for custom hardware acceleration. Then we have our own AWS Inferentia chips. We have the AMD G480 instances, which are great for workloads that need high resolution, like movies and also gaming workloads. And then finally, we have the Habana chip-based Intel instances. This is a wide array to choose from to find the capabilities that you need. If all those different options to choose from for compute seemed overwhelming, the good news is that we have the tools to help you discover and locate EC2 instances. The first one I'm going to talk about is EC2 Instance Discovery. AWS launched EC2 Instance Discovery last year to optimize instance selection for planned workloads. With this tool, you specify hardware requirements, and EC2 Instance Discovery will give you a comparable list of instances to review across price, location, and performance that fit your workload requirements. You thus have a single source of truth for the latest instance types, attributes, region or zonal offerings, and pricing. Also, this service offers a search and discovery experience via the EC2 Management Console and enables programmatic access to help you easily find and compare EC2 instance types to achieve high performance at minimal cost for each unique workload. To sum it all up, EC2 Instance Discovery lowers cost, optimizes performance, and enables you to get started quickly. The other tool we have is called EC2 Instant Selector. This is an open source CLI tool and Go library that does very similar things. It recommends instances based on your attributes. You can filter for what you need, passing those as flags for resource criteria like, say, vCPUs, memory, network performance, and much more. You can also aggregate those filters for more opinionated instance selections, or keep things flexible and let Instant Selector suggest instances for you. The other good thing is, if your workload is flexible to support a dynamic list of instances, you can code this as a Go library into your environment and let the tool specify the instances on the go as required. I've included a link here if you're interested in learning more. All right, so now that we have discussed all the different instance options and how to find them, you must be thinking, how do I scale with these many options, balancing cost with performance? Traditionally, when you think about cost, you may think that if I need to spin up more servers, I would spend more and not be able to meet my budget goals. If I don't do that for cost concerns, I run pretty tight, but might trade off performance by doing so. What if I told you that you can meet your performance goals at low cost? Today, you will learn how to take advantage of the different pricing options, use the right tools for managing capacity, and take advantage of the guidance and best practices to maintain performance. Eventually, it comes down to evaluating three attributes: price, capacity, and the guidance to incorporate those best practices into your environment. At AWS, we want to make sure that you're able to run your workloads in the cloud in a scalable, secure way. We also want to make sure that you aren't using EC2 that you don't need and you are fully optimized for your business. So we offer different pricing models, ways to automate your capacity management, and EC2 guidance to help you select the right instance types and sizes. I'll start with pricing, how you can achieve optimal price and performance by combining the different purchasing models for the right workloads. In terms of purchasing options, EC2 provides 4 different ways to purchase compute. The first one is on-demand instances. This is pay for compute capacity by the second with no long-term commitments. This is a great purchasing option for those workloads that are spiky and new, so you haven't defined quite your needs yet. The second one is reserved instances, popularly called RIs, where you make a 1 or 3 year commitment, and in exchange of that, you get a significant discount off of on-demand prices. This type of purchasing option is great for workloads where you have committed and steady state usage. The third type is savings plans. Now, this is a purchasing option that we launched 1.5 to 2 years ago. This is great in the sense that you get the same discounts as EC2 RIs with a lot more flexibility. And what I mean by that is something that I will discuss in the next slide. So this is a good way to access compute in a flexible manner for your workloads. And then finally, we have Spot instances, which is nothing but spare EC2 capacity that we are able to give you for discounts of up to 90% off of on-demand prices. The thing to remember about Spot is it's an interruptible service. So if there is a demand, if there's a surge in demand in our on-demand space, AWS reserves the right to take back a Spot instance with a 2-minute warning. And that is a reason why we say that Spot instances are great for those workloads that are fault tolerant, flexible, and stateless. So if you're thinking about flexibility, you should be focusing on savings plans and Spot instances. And then RIs and savings plans are a great way to layer extra savings on top of your on-demand instances. Just to summarize, these are the different purchasing options that you should be using for the right workloads to be able to scale both performance and your cost. More on savings plans. So you have 2 different types of savings plans, compute savings plans and EC2 Instant Savings Plans. Compute savings plans offer you the greatest flexibility with discounts of up to 66% off your on-demand prices. This is very similar to the convertible RIs if you're already familiar with them. In terms of flexibility, you can be flexible across instance family, region, operating system, tenancy, as well as compute options. So you could move from Amazon EC2 to AWS Fargate. For the next one, the EC2 Instant Savings Plan, it provides you lowest prices, so the discounts are more, up to 72% off, the same as standard reserved instances, on the selected instance family in a specific AWS region. So in terms of flexibility, it's a little less. Here you can be flexible across size, operating system, and tenancy. You choose the savings plan that suits your needs. And if you're interested in learning more, I've also included a link here. Let's talk a little bit more about Spot instances. So I mentioned that Spot is spare EC2 capacity. So it is the exact same infrastructure with the same security standards available across most AWS regions and instances. The closest analogy that I can give you is think about it as the Airbnb for infrastructure. Because it is spare capacity, we are able to give it to you at deep discounts of up to 90% off. In fact, it is the only way of getting the deepest discounts on EC2. The standard discounts that customers see are an average of 70%, and pricing is a function of long-term supply and demand. What I mean by that is the pricing is smooth and there are infrequent changes which are more predictable. Now, this is in stark contrast with the days when we had bidding in place, which was until 2017. So since we have removed bidding to make the whole pricing situation much easier for customers to understand, the pricing doesn't change as frequently as it used to prior to removing bidding. Let's talk about usage. So if your workload is flexible to support different instance types, sizes, and availability zones in an Amazon EC2 Auto Scaling group, and your workload is also flexible and fault tolerant, this is a great option for you. The reason you need to be flexible with the different attributes that I just mentioned is because think about it like in terms of an analogy, think about not putting all your eggs in one basket, right? So the more diversified your fleet is, the higher are your chances of staying afloat or lowering the impact of interruption if there is one. Let's talk about capacity. So I mentioned that Spot is an interruptible service. AWS can reclaim with a 2-minute notice, and interruptions happen when EC2 needs the spare capacity back. And to hedge against this interruption and the capacity issues, the way to do that would be to diversify your fleet and include as many instance types, sizes, and availability zones in your usage as possible, which is the last attribute that I talked about. Spot instances are integrated in many AWS services, and I'm going to talk about a few of them in this session itself. You will also find it in AWS partner offerings and open source software. There is a link that I've included here, which is our public roadmap for ISV and other integrations. And if you're noticing software where customers like you are benefiting and you would want to see Spot integrations in them, do let us know. We are always interested in hearing where else we can integrate Spot. A thing to note here is that our goal has been to make Spot as easy as possible for customers to use within your existing workflows. And you will continue to see this investment going forward. Let's talk about on-demand capacity reservations. This is a great option for steady state workloads where you have to manage capacity and discounts, where you can manage capacity and discounts independently. There is no commitment required. It could be created and canceled as your needs change. You reserve capacity by availability zone, and capacity is held whether you run the instances or not. You can share reservations across accounts. So that's a really good way to consolidate all your requests. You could update your AWS resource groups to organize capacity reservations into logical groups for different workloads, environments, and teams. And a tip here is we highly suggest that you combine capacity reservations with savings plans. Again, I've included a link here if you're interested in learning more. This slide is a great visual representation of how to think about your environment as your EC2 compute scales, right? So you use RIs and savings plans for known steady state workloads. You scale using on-demand for new or stateful spiky workloads, which are the orange bars here. The RIs and savings plans are the blue ones. And then you scale using Spot instances for flexible, fault-tolerant, and stateless workloads, the green bars here. Now let's evaluate a few of these from left to right. On the extreme left, you see databases. So databases are long-running, stateful, and they run best when you are deploying them on RIs and savings plans. Now, if you take job processing, it is a workload that is, for the most part, fault-tolerant. So if there is an interruption, the impact is minimal. It is also dynamic. So job processing can be run entirely on Spot instances. Now, if you take video streaming as a workload, video streaming is likely going to be needed to be online all the time, right? So it is real time. It is not tolerable to interruptions. And also it is something for which you may not be able to predict your needs. So video streaming is run best on on-demand instances. You get the idea. Our most optimized customers are ones that are running their workloads, combining the purchasing options, the right purchasing options for the right workloads in the portion that it is necessary, right? So this would be a great way to start thinking about all your consumption models and then see how in future you can scale, optimizing for both performance and cost. I'm next going to talk about capacity. So you saw all the purchasing options. How would you launch capacity against those purchasing options so you can take advantage of the broadest and deepest compute platform and yet be cost optimized? Using Amazon EC2 Auto Scaling, you can automatically scale instance types and purchasing options in a single auto scaling group to optimize for cost. What do I mean by that? If you see this visual on the right, it is an Amazon EC2 Auto Scaling group combining Spot, OnDemand, and reserved instances and savings plans in one single auto scaling group, right? So this is something that didn't exist before. So this is a relatively newer innovation and feature that we launched. The advantage to doing this is it gives you a lot better control over scaling your environment. And what do I mean by that? Supposing you have a workload that needs a baseline of instances to keep its lights on, right? So the steady state part of your workload, there is a steady state part of your workload. So you would want to put that on-demand instances and layer reserved instances and savings plan on top of it. But you also have a part of that workload that can dynamically scale up and down. That is the part that is also tolerable to interruptions. So you don't mind if it goes away. And that would be the part for you to put on Spot instances. And then there are different ways you can launch the Spot instances to optimize for what your goal is. If your goal is to minimize interruptions, you would want to use this first option that I have here, which is called capacity optimized. The way capacity optimized works, it deploys Spot instances dynamically from the deepest Spot instance pools in order to lower the chance of interruptions. So what do I mean by that? You are already familiar that the Spot instance pools, and Spot is spare capacity, the instance pool capacities also change dynamically from time to time, right? So this capacity optimized is an abstraction on that behavior where the time that you're launching the Spot instances, it will select the instances from the deepest pool and thereby just dramatically reduce the chance of interruptions for those instances. The second option is lowest cost. So as the name suggests, this is a way of launching a mix of on-demand and Spot instances based on the lowest available price that the instances have at that time. Again, depending on what your motivation is, if your goal is to lower cost, then this would be the way to launch those instances. And then you have prioritized list, which is using a prioritized list for on-demand instance types to scale capacity during a new spiky event. So what do I mean by that? Supposing that baseline of on-demand instances that I talked about, so you list out all the on-demand instances that work for you and listing out RIs, if you have bought any in the beginning, to make sure that those are utilized first because it goes in the priority order, right, for launching instances. So you would want to list out if you have any RIs that you have already bought first, or also layer savings plan on top of that. And then finally, we have support for on-demand capacity reservations, which is basically targeting EC2 capacity reservations within an AWS resource group using the resource group ARN. Here is a link to a really nice self-guided workshop. It will go through all the concepts that I just talked about and give you a very nice hands-on experience with all the best practices that I talked about. The end goal for all of this is to reduce cost, optimize performance, and then eliminate operational overhead. Let's talk a little bit more about exactly how this happens, how EC2 Auto Scaling does this heavy lifting for you. So as you can see, this is a CLI snapshot. Let's go through them one by one. So mixed instance policy is the policy that I said that auto scaling groups can now support, where you can combine the different purchasing options all together. So it allows you to provision on-demand Spot across multiple different instance types. And next, you list out all the different instance families and sizes that can be supported by your workloads. The more flexible you are, the higher are your chances of being successful with Spot instances. So, and it's not just the instance types and sizes, also availability zones. So those are pretty much the three metrics for you to basically diversify around and make your fleet more resilient to interruptions. Third one, you set a base capacity for on-demand instances covered by savings plan. So this is the base capacity that I had talked about, that you put the steady state part of your workload on this. The fourth thing to remember is you use capacity optimized allocation strategy to find the optimal spare capacity to reduce cost of interruptions. So this is just showing you what I had described in the earlier slide, that capacity optimized is a great way for dynamically launching it from the deepest pools, dynamically launching Spot from the deepest pools to reduce interruptions. And then the fifth one is you allow auto scaling to proactively rebalance Spot instances with an elevated risk of interruption to increase your application availability. So there is a flag here, capacity rebalance. You have set that to true. What I mean by that, I have the next few slides to talk about it. Again, this is a feature that we launched most recently during reInvent in November. And we are very excited about it because it is truly wonderful, as you will see shortly. So capacity optimized allocation strategy. This is a visual representation of how that would work. So supposing you have you are using three different families, like three different pools to choose from, and then three different AZs, US East 1A, 1B, and 1C. You have R5 large, C5 large, and M5 large to choose from. If you see in US East 1A, the R5 large is the largest pool. So when you use capacity optimized to launch Spot, it launches it from the R5 large pool. In the next one, US East 1B, C5 large happens to be the largest and the deepest pool. So when launching Spot capacity, this is where it launches from. And in the third one, M5 large is the largest one. It launches capacity from M5 large, right? So the way to, and the reason, the motivation for doing this is because this is going to reduce your chance of interruptions because these are the largest pools at that time. Let's talk about capacity rebalancing. So this is a new feature, as I just mentioned, which proactively manages the Spot instance lifecycle in an auto-scaling group. It increases the emphasis on availability, so it always maintains your target availability and also reduces the need maybe to over-provision Spot instances, which is a best practice that some customers had followed because the thought process was, if there are interruptions, this is not going to impact my fleet. The third one is it also provides a seamless and automated experience for maintaining your target desired capacity. The tip to remember here, this works best when you combine it with the mixed instances policy and also use capacity optimized allocation strategy for launching the Spot instances. And I have included the link here if you're interested in learning more about how this exactly works. So this comes in the form of a new EC2 signal that notifies you when the Spot instance is at an elevated risk of interruption. The signal can arrive sooner than the 2-minute Spot interruption notice, right? So it could be 10 minutes, it could be 15 minutes. In the worst case, it will arrive with the 2-minute interruption notice, but it will come. It also gives you the opportunity to proactively rebalance your workload to new or existing Spot instances that are not at an elevated risk of interruption. So whatever your target capacity is, it will always rebalance and maintain that target capacity. You could start checkpointing your work early to save as much state as possible. So this would give you more of a head start in terms of understanding which pools are at an increased risk, and you can start taking the right action that is needed for your workload. And it will also prevent scheduling new work on instances at that elevated risk of interruptions, thus increasing the chance of completing your work. There's a link here if you want to learn more about exactly how this process works. So how exactly would this work? I mentioned that it is an additional signal that EC2 sends you. So EC2 continues to monitor, the auto-scaling group continues to monitor for this rebalance recommendation. And then it proactively, if it finds that this rebalance recommendation comes, it proactively launches replacement capacity for the existing Spot instances when they receive this signal. It detaches from the elastic load balancer if that's necessary, and then runs the lifecycle hooks if you have configured on them on the instances that receive the rebalance recommendation. And then finally, it waits for the new instance until the new instance passes the health check before proceeding with terminating the old instance. If you noticed here in my animation, the old instance just disappeared, right? So as long as the new instance passes the health check, and when it does, it proceeds with terminating the old one. And this is how it would look in your in your CLI and in your console, right? So you set the capacity rebalance flag to true, which is something we saw in the last one. And in your console, this is only a checkbox. So you opt in if you decide to receive this, if you decide to enable this rebalance signal. Now, as you can see, it's extremely easy. It's extremely easy to take advantage of this feature. It's just like a one flag and one checkbox. The good news is you can also take advantage of this with AWS Cloud Formation templates, if that's the thing that you're using. This is a visual representation of how capacity rebalancing will actually work. As you can see here, we have 3 different Spot capacity pools that are being launched using capacity optimized, which launches the Spot instances from the deepest pool, minimizing interruptions. And then we have the 3 AZs here, US East 1A, 1B, and 1C. Now, if you take 1A, for example, the largest pool here is R5 large. So using capacity optimized, R5 large instances are launched in this AZ. Now, watch carefully what happens. The R5 instance gets a rebalance recommendation. This is then marked for termination. The autoscaling group will detach it from the load balancer and then start running lifecycle hooks if you have configured them. What it also does is it takes a C5, the next largest pool, and starts the health checks on this instance. So once the C5 instance passes all its health checks, what happens next is the C5 goes and takes the place of the R5. The R5 is terminated, and it also is marked here that C5 is now the largest pool and the R5 pool has shrunk. Let's go to the next one. So here the largest pool is C5 large. Capacity optimized launches the instances from the C5 pool in this AZ. Now, one of the C5 instances will get the rebalance recommendation. It is marked for termination, gets detached from the load balancer, and starts performing lifecycle hook actions. And at the same time, it picks up a M5 large from the next largest pool and then starts the health checks, autoscaling group. And once the M5 passes the health checks, the C5 is terminated, the M5 goes and takes its place, and now the M5 is marked as the largest pool and the C5 has shrunk in size. And I'm not going to go through the 1C, but it works the exact same way. You get the idea. All right. So for those of you that want to use a blend of Spot instances and on-demand instances and optimize for cost, availability, and performance across, let's say, different types of workloads, you can use an autoscaling group, or you can also look to use a service that has integrated an autoscaling group so that you can use all its powerful features. For example, if you're running a container platform, and let's take, for example, the Amazon Elastic Container Service or Amazon ECS. If you would like to run and optimize for cost optimization, as well as performance and availability in your ECS clusters, you can take advantage of Spot instances because ECS can tap into autoscaling groups. And you can do this through what are called capacity providers. If you take a look at ECS, you can launch capacity providers that are based on EC2 autoscaling groups, and then you can have ECS automatically provision your capacity for you. You can have it automatically scale up and scale down and let ECS, with a combination of EC2 autoscaling, take the undifferentiated heavy lifting off of your shoulders and allow the ECS cluster and autoscaling to work together to provision capacity at scale while optimizing for cost, all at the same time. If you would like to learn more, please do check out the link to understand more about how Spot instances can be utilized within ECS. Next up, Amazon EKS. It is a great option for those of you that are running Kubernetes-based workloads. It's a fully managed Kubernetes environment on top of AWS. EKS can also be used with EC2 Autoscaling. So you can enable a lot of what we just talked about with EC2 Autoscaling in your managed Kubernetes clusters. AWS recently announced the support of Spot instances within managed node groups. Now you can easily provision Spot instances on EKS. You can configure multiple instance types, and EKS automatically configures best practices for you. Capacity optimized, labeling of Kubernetes nodes with capacity type, and AHG tags for cluster autoscaler auto discovery. It can do managed node updates and graceful termination if there is an interruption. This Spot instance lifecycle management is integrated with capacity rebalancing that I had discussed earlier. You don't need to deploy automation to handle interruptions. You get a fully managed experience. By default, nodes run Amazon Linux 2 EKS optimized AMI, but you can use your own AMI or config with launch template support. This shows how you can implement EC2 auto scaling groups in your EKS clusters. You can also invoke Spot instances in your self-managed Kubernetes clusters on AWS, where you have to handle some of the automation around lifecycle management yourself. Therefore, you can now blend your purchasing options of OnDemand and Spot and scale with savings in mind with EKS or with self-managed Kubernetes on AWS. And once again, there's a link there if you are interested in learning more. Let's talk about Amazon EMR. EMR is a managed big data service on top of AWS. A lot of customers take advantage of cost optimization inside of Amazon EMR by tying in the use of Spot instances. The great thing about EMR is that it recently launched a new feature called allocation strategies, which allow you to provision EC2 instances in an Amazon EMR cluster. So allocation strategies effectively allow you to tell EMR how to allocate your capacity with the goal of optimizing for lowest price, as well as reduce likelihood of interruptions. So when you're using on-demand instances within your EMR cluster, you have the lowest price allocation strategy, which says, look across, say, all instances that you have allowed me to use, and look for the lowest price instance types. When it comes to the Spot side of an EMR cluster, you can use allocation strategy to use capacity optimized, which I've discussed a few times now, which effectively will launch Spot instances into from the most available Spot instance pools, therefore reducing the likelihood of interruption to your EMR workload. You can also provide up to 15 different instance types per task in EMR Instance Fleet when using allocation strategies within your EMR cluster. And why this is a very important feature update is because if you think back about the best practices on Spot instances, the more diversified your fleet is, the higher are your chances of lowering the impact of interruptions if there is any, right? So previously it was less than 15. So now that we have increased the number to 15, it gives you a lot better opportunity to diversify enough to increase the resilience of interruptions in your EMR cluster, to increase the resilience to interruptions in your cluster. Do take a look at EMR for your big data workloads for Hadoop and Spark-based workloads. And if you would like to run through a self-guided workshop, there's a link here. The self-guided workshop will take you through running a Spark cluster on Amazon EMR, and it helps you understand how to take advantage of all these strategies that we just talked about. Another great option, and the last one for discussion in this section, is AWS Batch. So for those of you that are running batch processing workloads on top of AWS, consider using AWS Batch because it provides built-in support for EC2 Auto Scaling and Spot instances that we have been talking about. It's a fully managed batch processing service, and it has what is called built-in cost-optimized resource provisioning. What this is effectively is the ability of launching into allocation strategies designed with capacity and Spot capacity, as well as best fit progressive, which means looking at the most cost-effective on-demand instances to use for your batch processing workloads. So for example, you can actually combine on-demand and Spot compute environments within AWS Batch in order to optimize for cost, scale, and availability. If you would like to learn more, do check out the link. And if you would like to run through a self-guided workshop, there's a link for that as well that allows you to run through the particular use case. So finally, we want to take into consideration guidance. We want to understand how if we have done a good job at optimizing for performance and for costs within our environments. The best way to do this is to tap into a service called AWS Compute Optimizer. Now, AWS Compute Optimizer was launched to help you understand how am I optimizing across cost and performance within my environment. This tool uses machine learning models trained on millions of workloads, looking at resource utilization, configuration, and performance data to help customers optimize their compute resources for cost and performance across all the workloads they run. You can take advantage of the recommendations in Compute Optimizer to reduce costs by up to 25%. This tool delivers instance type and auto-scaling group recommendations, saving time and making it even easier for you to compare and choose the right compute resources for specific workloads. So today, the tool is able to recommend across 145 plus instance types across the M, C, R, T, and X families. If you would like to learn more, take a look at this link here that I have on the slide and learn more about how Compute Optimizer can work in your environment. So I have an example slide here that helps you understand a bit more. With AWS Compute Optimizer, it allows you to easily choose which instance types are optimal for your particular workload. And it does this by analyzing CloudWatch metrics within your environment. The CloudWatch metrics are probably running against your workloads, and then it helps give intuitive and actionable recommendations, taking into consideration the metrics that it's monitoring. It helps recommend optimal EC2 instance types. It helps you optimize for performance, and it helps you reduce cost by making recommendations to help right-size your workloads. It is able to recommend up to 3 different instance types per workload. And recently, it also launched a feature to take an additional EBS metrics to help you understand the full picture of your EC2 workload so you can optimize. The great news about Compute Optimizer is that it's available at no additional charge. All you have to do is go into your console or into your CLI, simply turn on Compute Optimizer, and then check back against the recommendations that it brings to you across your account. Takeaways from this session that I would like to leave you with. First thing to do is to understand that EC2 is designed to provide the right compute for virtually every workload. We have workload optimized EC2 instance types. Do take a look at all the instance types that are available to you, and also think about how many different types you can use within any individual workload. Second, understand how to optimize for cost, lower costs, and innovate faster by tapping into both Spot instances as well as savings plans. If you combine these, it is the best way to optimize for your savings, scale, performance, and availability all at the same time. Third takeaway, remember to automate cost and capacity optimization by tapping into EC2 Auto Scaling. It is a tool that allows you to blend what we just covered here in the sense that it tells Auto Scaling what you are able to use. If you tell it how flexible you are, what different instance types you can use, which availability zones you can tap into, which purchasing options and instance types you can leverage, and then let EC2 Auto Scaling go figure it all out, it becomes extremely easy. And if you would like to tap into the integration of auto scaling with other AWS services, by all means do that. Take a look at ECS, EKS, Batch, EMR. Those are few of the many AWS services as well as third-party services that have integrated to leverage EC2 auto scaling and provides the same benefits. And then finally, think about optimizing your workloads by following up on recommendations coming from AWS Compute Optimizer. Do turn it on, take a look at the recommendations it gives you, and then take advantage of understanding those recommendations and going back and updating the instance types that you have used to power your particular workloads. Brings me to the end of my presentation here. I want to thank you for the time you spent with me today. We have some time now for Q&A. I have a few members of the EC2 team with me to help out with this part, so please go ahead and type your questions in the chat window. We will get to them shortly.